Thanks, Harold. And really, thanks for inviting me to be here. It's my first time to this part of the country, and I have to say I'm quite impressed. I'm from Austin, Texas, where it's green and hilly with lakes, and I get here expecting Rust Belt, like most people from outside of the region, and man, this is gorgeous. So I'll have to come back. I'm also pretty impressed with the energy presence here, and I hope it hasn't been hit too hard with the downturn that we've all seen. Just switching over real quickly here to a different computer. I've got some examples, and we are going to have that UAS question and answer panel. So where I would normally take questions during the presentation, I'm happy to do that. Let's save them for the panel, because we're going to have several experts on stage to help answer questions, and maybe one person knows something another person doesn't. And push the magic button. We're good, we're good.
Switch button to HDMI.
Yeah, but it's going to a different screen for the audio.
Yeah.
Here we go.
Displays.
Sources.
There you go.
How about that? Okay, max that out for you. Okay, so I'm going to flip through some of the technology and where we are with the technology as far as productizing and commercializing the technology, because everybody's interested in drones. It's a hot topic. But what we're interested in as GIS people is a better base map, richer content, and faster turnaround time. Those are really the keys that UAS bring to the table. So I'm going to focus on those themes as we go through here and hopefully give you sort of a state of the art of where we are with the technology. A little bit about the background, as was mentioned, the parent company of Flightline Geo has been in GIS for 25 years, Esri partner. And again, just starving for better map content. We got into UAS. We were fortunate enough to be involved with some DoD and government projects on wildfire research where they had obtained all the permits. And we didn't have to worry about, because there was no 333 process 10 years ago. So we rode on the back of some of those projects because they were quite competent at flying their UAS, but they didn't know what to do with the content coming down off the UAS. So we came in as GIS professionals dealing with that content and making it useful. But that got us an early entry into the technology. So we began to immediately figure out what's useful, what's hype, and we're going to talk about the hype cycle of UAS here in a moment too. We do have the 333 exemption now since 2015, so we can operate on open commercial projects, not just university and government projects. Well, for us, we have been involved with UAS, but in the 2012 user conference in San Diego, this is where it all started to go big for GIS users. That's our UAS that we fly and have flown up until this year on stage during the opening session with John Calkins there. And he's talking about how this is coming. Now, this is 2012, and he's saying this is all coming. And since that time, what we've been doing is working with this commercial system, which the trail has been blazed for us in other countries. You look at Australia, New Zealand, Europe, parts of South Africa. They're all doing this and have been for close to 10 years now. So we have the benefit of standing on their shoulders and learning from their mistakes, most importantly. Because these systems can come down, right? And I want to learn everything I can from the guys who've already crashed a few before we go out there. And fortunately, we haven't crashed yet. This is the hype cycle, and we're going to come back to it at the end, and I'm going to tell you where we are. Now, if you've heard of Gartner research in IT and other technologies before, they're a well-known research company, and this is the Gartner hype cycle, and we're going to apply it to UAS. But you can picture already, in the beginning, you have a technology trigger. In our case, it was the computerization of the autopilots and battery technology. But then you have everyone getting on board the bandwagon and getting all hyped up on a technology like drones. And it takes off like crazy. And you reach that peak of inflated expectations before you go plunging into the trough of disillusionment. Well, we're somewhere in there right now because people are figuring out what's real, what's not, what's commercial, what's not. So we're going to come back to this at the end. The elements of UAS for GIS, at least the way we see it, we have platforms, sensors, processing, and delivery. And you can switch out the components. You may have different platforms for different needs, and we're going to talk about some of those. Obviously different sensors for different types of applications, processing which can be done on a desktop workstation, or it may require heavy-duty cloud computing capability. And then last but not least, delivery, which could be anything from handing over a thumb drive if it's a small project to cloud-based delivery or streaming data. Let's talk about some of the platforms. These are a couple of the rotor platforms that we use. We do use some rotorcraft, and they do have certain things that they're very good at. What are the drawbacks, though? They have a shorter duration, for one thing, and they carry smaller payloads, typically, which means lighter cameras, lighter lenses, lighter sensors, and so you start compromising on your content and your flight time when it comes to rotors. But they're good for very small projects. And to me, a small project is anything from 1 acre to 100 acres. So if it's under 100 acres, it's not worth putting up the big fixed wing bird. Why risk it? We can do a rotorcraft, as long as we can carry the right sensor. Another good thing about the rotorcraft is they are pretty easy to operate or learn to operate. Some of them you can literally learn in 5 minutes. Others take a little more experience. But they are very easy to use, and so most people start off with rotorcraft. Fixed wing is where we do the bulk of our work. We have a longer duration. We're talking 1 to 2 hours or more, which we'll talk about in a minute. They can carry heavier payloads and cameras, and particularly the lens. Any photographer will tell you that the lens is equally, if not more important than the camera. So if I can't carry a nice lens, my imagery is going to be limited. So the quality of those cameras and lenses could be much better, but downside, they require a lot more training and experience to operate safely. Just for example, my crew and myself, when we first got this particular UAS model, we went through 65 hours of factory training. And then they said, we want you doing this at least once a week, every week, just to stay sharp. So you have to work at that kind of a tempo to build the experience and capability. By the way, this one is kind of unique. It has a parachute, which is an emergency feature, but it's also the primary landing mode. So we can drop into some very tight locations. And in Texas, where we do a lot of our work, at least, it can be fairly rugged and no nice place to land on a belly landing. And with the parachute, we can drop into an area about the size of a tennis court. Very quickly, that's the launch, and we like hand launches for several different reasons. We don't have to carry that extra piece of equipment in the form of a catapult, which is just something else that could break, plus we have to carry it. And then the other thing is, with the hand launch, if you have a wind shift right at launch time, the operator who's holding the drone feels this. They check that right before they throw it, and they can actually just turn into the wind. You always launch into the wind. So I have had situations on the government project we worked on where they set up a stationary catapult where they thought the wind direction was going to remain, and it came time to launch, and they hit the button, and the wind had shifted almost all the way around to the tail. And I watched a $150,000 drone bite the dust. So the hand launch is nice because you can feel what's going on with the wind and do a quick check before you actually throw it in the air. Where does this UAS technology sweet spot sit? Well, satellites are way up there, but their resolution is 12, say 18 inches or so, and then we fly over an area every so often on a cloud-free day. Manned aircraft, on the other hand, are getting pretty good. They're getting resolutions in the 3 to 12 inch, some experiments down as low as 1 inch. It's not real common yet, but it can be done. And they can cover a lot more area than a UAS. So I try to be practical with this. I don't think the UAS is the silver bullet for everything. For projects that are 100 square miles or 100 linear miles or more, because of the technology constraints and more importantly the FAA constraints on beyond line of sight, 100 miles is about the crossover point where it makes more sense probably to go manned. Now, you give something up, you probably give up some resolution and you're not getting that point cloud that you get with a UAS, but if you just need a base map, that's the crossover point in terms of economy. The UAS, we're operating at 400 feet with the fixed wing. We don't like to go lower than that, and we don't like to go higher than that because we get in trouble. So 400 feet is the optimal altitude for that. And at 400 feet, we're routinely now producing 1-inch resolution base maps and point clouds. And we're covering around 2 square miles per flight. That's about 1,500 acres or so. Depends on the wind conditions and some other things. But that's our average flight time right now at coverage area with the fixed wing. On a linear terms, we're doing about 10 miles per flight, and we're accomplishing that by using visual observers and remaining within line of sight of those observers. We'll talk about that again in a minute. Rotor UAS, as I mentioned a while ago, 1 to 100, 1 to 50 acres-ish, because you're only flying about 15 minutes. Recent project that we captured was 2,700 acres. That's a little over 4 square miles. It was accomplished in 3 flights. Now we could have done it in 2, but we had a new camera and we were checking to make sure that we weren't filling up the camera memory and overflowing the memory. So we came down a couple of times to check that out. But we took 3 flights. It could be done in 2 flights. 2,500 photos. They were 36 megapixel photos. And we did have survey grade ground control. Ground control is very, very important to quality UAS content capture. Don't let any manufacturer or any service provider tell you you don't need ground control. The military skips ground control sometimes because they can't send a guy out in the battlefield with a GPS unit to stand there, but they also are dropping bombs that are good within a certain radius, right? With GIS content, we want to be within a foot, and maybe on an engineering project, we might want to be within an inch. So you could have ground control at one of those levels, sub-foot with a high-quality handheld GPS, sub-inch with survey-grade ground control. But you do need ground control. No more survey. How do we operate in the field? Pretty light footprint. This all goes in our travel case. We have a ground station. We have the UAS. We usually carry 2 of them. We don't trust just one. That way, if we make a trip to a site, something goes wrong during pre-flight check, or a cable broke, or something crazy like that, we just put that one back in the box, break out the other one, and go. But it operates off the tailgate of a pickup truck, typically. This is really some of the magic of the system that we're using. It's an Esri-based runtime mil-spec capture system. That's a lot of words. But the important thing is we're getting real-time feedback on the image footprints as they're captured. And they're adjusted for the terrain. As you're flying along and the ground's going up and down, your pictures are shrinking and swelling. Now you might not know that if you did a pre-programmed flight plan, which these drones are capable of doing. But if you throw one up on a pre-programmed flight plan, there's a chance that you could come back with either reduced overlap, maybe you were looking for 80% overlap and you got 50, or missing spots, just like mowing the grass. You may have missed some spots, and that's not something you want to find out when you come home. You want to know that when you're in the field so you can correct it. So this real-time capture system actually shows us that we've covered up the area to our satisfaction before we ever land. And if we did happen to miss a spot, we can go back over and catch it before we land the UAS. So this is one of the reasons we really like this system that we're using. The results are an image mosaic and a point cloud, which is GIS ready and slides right into Arcgis after processing. Don't get the idea this is ready when we land. There is a significant amount of processing depending on the project size. And speaking of project size, this is you're the first in the US to hear this being announced here today. We're going to make a bigger announcement at the Esri conference next month. We're going solar. We're going to basically quadruple our flight time with our UAS by adding solar panels to the wing surfaces. And instead of flying 1 to 2 hours, we'll be able to fly 4 to 8 hours until the sun is gone. And what that means is fewer launches and landings, that's the risky time. Stay up there, efficiently capture the project, larger project sizes, more efficiently captured. So quadrupling the flight time is a really, really big deal. So you're the first to hear about it. Let's talk about sensors. Most of our work are GIS folks that just do need a better base map. Maybe they don't even care about the point cloud, and the point cloud is just filed away, and all they want is a better base map. So this is an idea of some of the base map quality at 1-inch resolution that we're routinely capturing, and I really like this one because it's a ranch, and if you look at the gate, you see the shadow of the gate on the driveway there, and you can actually read the letters of Rocky Creek Ranch. So it's one of the coolest pictures that we happen to capture. We also, on sensors, use multispectral and hyperspectral. If it's an agricultural application, or in our case here, with this audience, how about spotting wetlands? The same sensors that are good for agricultural analysis are great for spotting wetlands if you're planning a route for a project or a new pad site. Wouldn't you like to know if there's wetlands before you send the crew out? So these same sensors can be flown along a prospective route to spot these different trouble spots just by converting an ag sensor into a wetland sensor. This is just another example. Different color band mixing and matching. One of my business partners is a PhD in remote sensing. I'll let him figure out all of the sensor stuff. I focus on outreach, working with customers, project management, and the flight operations. But he can mix and match bands to see different things. In his PhD project at Texas State University, he actually analyzed point clouds of vineyards to get grape yield. He could see grape clusters in the point cloud. So by analyzing the growth of those clusters over time, you can project the time it's going to take to harvest and what the yield might be. So anyway, different sensors for different projects, and we let the customers tell us. We don't try to tell the customers, you need this, you need that. They come to us with problems or issues, or we need to be able to find this or see that, and we match it up to the right sensor. Another sensor type, you're probably hearing a little bit more about it. It hasn't really taken off like they had hoped because it was too expensive for the right kind of camera, is full motion video. The military's been using this with Predator, and we worked on the Predator program for over 10 years. And what it is a geo-enabled video. And it's not just a video that has the lat-long coordinates of where it's been shot, as you can track around a little dot on the map. It actually is video that you can pause and digitize features inside the video player. Those features go into your GIS. So if you fly, let's say, a pipeline corridor, and you're looking for intrusions, okay? You pause the video, outline it, attribute it, and then go on. And at the end of the day, you preview this video in your office where it's comfortable, and the features have gone into your GIS. Well, it didn't take off as fast as Esri would have liked because the cameras used to cost $500,000 or $1 million or more. Now there are methods of actually creating the right kind of data with much less expensive cameras. So we're going to see full motion video really come into its own as a source. Now you're not doing point clouds, you're not doing that kind of work, but this kind of automated data capture and pipeline monitoring, things like that, very, very suitable. Also disaster response. So let's take a look at a few examples. You've probably seen some of these already, different presentations, but let's look at side by side sort of current state of the art with manned systems like a county will fly a mission or the state will fly a mission. We have an ongoing state program in Texas. They capture either 6-inch or 12-inch manned photography. We're going to compare side by side the resolution, but also bear in mind the turnaround time. Many of those county projects and state projects, the turnaround time on the imagery can be 6 to 12 months. And by the time it's delivered, the data are obsolete. So that's the other half of the importance of UAS. Same feature, left and right, same scale. Well, on the left is the county GIS in the Austin area called CapCog. It's a co-op of counties. Captured in January of 14, delivered in January of 15. So it took 12 months to get the data. And on the right, captured with the UAS. Now this is the old camera, it's just 2-inch resolution. But you can see side by side, 12-inch versus 2-inch. But maybe more importantly, the turnaround time, 12 months versus 2 days. And this is just a series I'll flip through. A house, the one on the left, you can't even tell there are different levels to the rooftop. On the right, obviously you can see that. You can see the different rails on the fence. We caught many of the same commercial vehicles in the parking lot. And on the left, it's kind of a blur. You can tell it's a pickup truck. But on the right, you can see toolboxes and ice chests and things like that. Now here we go. Here's your energy example. This is what we were capturing on the project. Again, on the left, captured in January of 14. This is a valve site construction. It's not complete yet. We flew in August. It is complete. Their image came out January of 15, incomplete. Ours came out 2 days later in August, complete. So that's really something to take home. The turnaround time is a big advantage on the UAS. Smaller project sizes. Arcgis Base Map. They're using a variety of different sources like Digital Globe and others. This is the same house captured left and right, and on the right, they've made some additions. They've got solar panels now. We spot that. It's not in the base map before. We can actually see the pool cleaner in the pool and count the shingles. And there are insurance companies looking at that kind of thing. Facilities, 1-inch resolution imagery. We can see the power lines themselves, not just the towers and the shadows of the towers. You can see the actual cables and guy wires, things like that. Here's a 1-inch shot of that same valve site, just from a different angle. It's great for monitoring change over time. With the turnaround time, it's quite affordable, even some of the stuff you can do yourself. Let's talk processing. Take some horsepower. If you're flying and capturing a square mile or 2 square miles or 4 square miles, it may or may not be processed on your desktop workstation, even a nice one. We processed this project on a 16-core, I believe this was 120 gigs of RAM system, and it took a day or two to process even on a system like that. So there are some organizations popping up with cloud processing services offerings. The problem with that approach is I've not seen one yet that's really truly one click. You know, throw a bunch of images at some software and something good comes out the other end. It's not like that. There is some intervention. There is a need for an analyst to oversee the project. You have to align to ground control if it's a meaningful project. So it's not something that's completely automatable like that. Maybe on the consumer level or the entry level, but not when you have to align to ground control in particular. That's a manual process of identifying the ground control points, clicking on them, and go on to the next one. So you can't do that in an automated method. Some of the other processing that we do, this is kind of cool. It's very much like what we do with LiDAR, where you take off that first return and remove vegetation and structures from the LiDAR imagery. Well, in the past, this was not possible with UAS-derived, photogrammetrically derived imagery, but now we can. There's enough software and enough horsepower in the hardware to actually analyze, classify, and remove structures and vegetation, leaving you with a bare earth like you see on the right. Why does that matter? Well, I don't want to generate contours of trees and buildings. If I'm looking for elevation contours, I want elevation of a bare earth model. So it's now possible through a combination of processing software and hardware. And so what do we produce? We produce 3D contours. These happen to be 12-inch elevation contours of a project site. We actually produce 6-inch contours for the client and say, ooh, too much, back off. So we reduced it down to just 12-inch contours, which they're very happy with. Because side by side, that's what they were working with before. 20-foot USGS DEM-derived contours versus 1-foot contours at the same site. And just if you click on the contours, you know, like any GIS layer, this slide's really in there for non-GIS folks. You click on a contour and you get the value of that contour. So it's an intelligent contour, not just lines. Speaking of lines, we worked with a very large pipeline company who you'd all recognize their name, but I'm not going to mention them here today. They're building a new facility in Louisiana, and it's about 450 acres, one flight. Took us about 40 minutes to map the area, processed overnight. And they came to us after the fact and said, hey, we love the imagery, we love the contours you generated, but we need planometrics. Their CAD guys had seen this, the engineers had seen this. Can you do planometrics? Sure. So we had our CAD technician generate edge of pavement, center line of the stream, center lines of the roads, that kind of thing, which saved them a lot of time. And again, it's from the fresh imagery, not the 2-year-old imagery they've been working with. So we also do some of that. Let's talk 3D. You've seen some point cloud examples, and this is just tipping the point cloud and colorizing it by the RGB. It's pretty cool stuff. And it's great for this construction monitoring project that we were working on, because that valve site happens to be over a creek called Barton Creek outside of Austin, one of the most environmentally sensitive areas in Texas. Barton Springs Pool in Austin. Barton Creek goes into Barton Springs Pool, so you don't want to spill anything in there. It'll be all over the news. So we monitored during the construction. Now I'm just going to let this roll a little bit and then we'll jump out of it. But basically, once you've got the point cloud, you've got the imagery, if there's a need for it, you can produce fly-through type animations. This is not flying with a video camera. This is the actual point cloud where we can go in and fly down the corridor. There happen to be 3 pipelines side by side in this case. And what's cool is the trees actually stick up like they should. The valve site features, the solar panels on the valve site. You see all the terrain. So for management, public meetings, all those sorts of applications, this is a great tool for showing. Not a lot of science here. It's pretty flashy, but that's what it's for. Is for things like public meetings or meetings with management. It was our project, and you can do this over time and show the progress of the project. If I can get it to jump on. Okay. Now I'm just going to show you some quick 3D examples to show you where we've come since then. That was 2014. I just want you to look at the level of detail of these buildings and these trees as we flip through these examples. It is quite detailed. You would think that some of this is terrestrial LiDAR, but it's not. This was all captured from the same mission that produced the Ortho Base Map, flying from the fixed wing UAS. Golf course. So some really, really realistic point clouds. And a lot of folks see the point cloud and they think it's a video or they think it's a perspective oblique, like pictometry. But it's not. It's the actual 3D data. And you can spin it around and look at it from different angles, and it's not some kind of a stretched down texture down the sides. It's the actual image of that feature in 3 dimensions. So it's metric, you can measure things. So ways that we deliver imagery, we'll still do it the whole way with a hard drive, but the data are getting so large that people are asking us to put it on a cloud server, either their own private cloud or Dropbox or something of that nature. Very, very common way of moving the data right now. But really, that last one that's highlighted in yellow, the online streaming, is what we're moving to more and more. A lot of our customers do not want to store and serve up that data to their end users. So we're doing this streaming through ArcGIS Online, and it opens up the possibility to field crews. They can now take their iPad or their iPhone or their Android device out in the field and see themselves right there on the map as the blue dot. So if they need to navigate around the project, because it's streaming down, it's just like Google Maps. They can see themselves walk around on the project. And if you have other layers that you want to load up, like property ownership or right of entry or things like that, you can click on it and get that information. So it's an intelligent map taken to the field. Now, very quickly, because I just have a couple more minutes, I want to show you some disaster response applications. We had a flash flood almost a year ago in central Texas. You might have seen it on the news. 40-foot wall of water came through here, washed some houses downstream. 8 people were killed in this accident. There was a search and rescue that went on for weeks and weeks looking for people. And we were initially involved on the GIS side because I have a background in disaster response. There's Deepwater Horizon Command Post, the GIS lab. We called it the Bat Cave. And we were called in to set up this common operating picture for the response. But a few days into it, they said, "You're the drone guys, aren't you?" And we said, "Yes, we can do that." And they asked if we could fly an 8-mile stretch of the river and spot vehicles leaking fuel and oil and all this kind of stuff into the water, because it was still dangerous to go out there. And so we actually asked for and obtained one of the first that we know of, beyond visual line of sight permissions from the FAA, meaning we mapped the entire 8-mile stretch of river in one flight without seeing the drone. Now, we did put some visual observers out there to keep it safe, looking for other vehicles, because there were 17 manned helicopters working and doing search and rescue work. But it's one of the very first that I've ever heard of. It was during an emergency, so we had an emergency COA to do this, and we had to establish an air boss to interface with the manned assets. But it is possible, at least, to obtain beyond visual line of sight. All the data, it's pretty high quality stuff. I think it was inch to inch and a half, and it was visually stunning, but it was also very useful because we brought it into the common operating picture where it was accessible to folks in the command post. They could click on it, see other layers, find out about property ownership, and it's all right there. It just slid right in and replaced the old base map. And I'm not going to do it here, but you can go to our website and see the before and after, we call it a swipe map. And it's online, it's streaming online, and you can look at this. You can zoom in on it, pan down the river, go left and right to see before and after. This was a very, very valuable tool after the fact when they were looking for removal of debris piles, which is a major project in any kind of hurricane or flood. Just a little bit on the regulations. We deal with 2 layers, federal and local or state. The feds, all they care about really is air safety. So we comply with that. It's the state or local level that you're going to run into the privacy issues. We're fortunate in Texas that 3 years ago in the legislative session they passed a drone privacy law, but they specifically allowed mapping, pipelines, electric transmission lines, and all the stuff that we do. So if we have right of entry, we can fly over it. So we're in a good position there, and many other states are taking the same posture. Others are a little more conservative or restrictive. So we have to check in each state to find out what the rules are in that local area. The draft regulations are out there right now, and it is expected within the next 30 days or so that we're going to get a new set of rules from the FAA that will do away with the need for a pilot on the project. You'll be able to have a certified drone operator who's passed a test on airspace, which is really why they require a pilot right now, so that you know if you're in authorized airspace or not. That is probably going to go away, and we're going to see that happen very rapidly this summer. So the 333 process is interim. It sounds like it may even go away. We're going to find out within a month or 2. Okay, so wrapping up here, back to the Gartner hype cycle. Based on what we've seen and what we've learned, the overall USA industry right now has hit the peak, and we're about to dive into the trough of disillusionment. Folks are going to get drones, start doing projects, they're going to be turned off by the capability to capture an area of interest, or the quality of the output, or maybe someone told them they couldn't do ground control. You really need the ground control. So they're going to find out what it's really all about here over the next several months or a couple of years maybe. But once you pass through that trough of disillusionment, commercial operators in particular are finding out what's real, what can we really do, and where can we target our efforts. And so that's where we are right now. And again, we have the benefit of these overseas operators that we've learned from and projects that we worked on with the government and the universities. So we're about to head into this plateau of productivity, and that's where it gets fun. And that's where we are now. I'll mention very quickly, I do have 2 articles in this month's issue of ArcUser magazine. The first one's on that flood disaster response and how UAS and GIS were integrated. And then secondly, there's sort of a how to get started article, which covers in more depth what I've talked about here with the platforms, sensors, processing, and delivery. And then what's neat is you can pass this along to your boss, your cohorts at work that couldn't make it. Check these articles out. They're non-commercial. We're not trying to sell anything. But we're just trying to say, here's what you need to look out for if you're getting into UAS. And here's what you can expect. Always like to wrap up with some dronies. It's a selfie taken from a drone. We usually capture ourselves. We're somewhere nearby the project area, and I just throw a few of the funny ones up there to show you. And then last but not least, the contact information. If anyone has questions, I answer emails all day long. Be happy to answer your questions on UAS or GIS, our experiences, what you might be thinking about doing. And also, we post a lot of our projects when our customer allows us to talk about it on the social media sites. So follow us on Facebook and Twitter and things like that. And when we can post projects that are cool, we put them out there and say a little blurb about them. So you can find us on there as well. And I'll just thank you for your time, and hang around for the question and answer panel coming up here in a couple of hours, because that should be really good and you can answer all of your questions. Thank you very much.